Okay, there we go. All right, we're going to look at proofs for CPCTC. Okay, so remember CPCTC stands for corresponding parts of congruent triangles are congruent. And remember, we never want to use this to prove two triangles are congruent, only to prove that their parts are congruent. Okay? So we're going to start, I'm going to actually start with, I'll start with number 1. Okay. So we're looking at number 1. So we've got MK is congruent to OK. We've got KJ bisects MKO. So I know these two angles are congruent to each other. What else do I know about this picture right here? Yep.
That JK is congruent to JK because of reflexive.
Bireflexive, good. Do I know that these triangles are congruent to each other now?
Yeah.
By what?
Side, angle, side.
Yep, side angle side. Okay. All right. So we're just going to go through this because the last one, we are going to use CPCTC, but then we have to use one more thing after it, which is a little weird. Remember, this is my statements. This is my reasons. I'm going to start with number 1. I'm actually going to put these both on the same line just to save room because we don't have a lot. MK is congruent to OK. And KJ bisects angle MKO. That's given. Okay. Then we're going to say, number 2, angle MKJ is congruent to angle OKJ by definition of a bisector. Okay. What comes next? I've done all the givens. What else do I need? Let's look. I've done all the givens. What else do I need? Go ahead, Layla.
KJ compared to KJ using the reflexive.
Good. Okay. Now, can I say the triangles are congruent? Yeah. Triangle JMK is congruent to triangle JOK by side, angle, side. Okay. So what does bisecting mean again? It means to cut something in. Okay, we want to know that KJ bisects MJO. So do you guys get that that would mean that angle MJK has to be congruent to angle OJK? Does that make sense? That's my CPCTC. And then I can say, step 6, KJ bisects angle MJO by definition of a bisector. Sound good? Okay. This next one we're going to have to, I think there was a small issue with a line not being drawn all the way in. Okay. So we know AB is parallel to oh, excuse me, AD is parallel to BC. And it's saying AD is congruent to BC. Okay? We should have a line drawn in here. So, it was obviously a typo that the line should be right here. Okay. So, then we're going to have, if we have alternate interior angles, is going to be used to find that those angles are congruent. And then we're going to have, AC is congruent to AC by reflexive. And then we've got side angle side. Okay. So step 1. AD is parallel to BC. Given. Number 2. Angle DAC is congruent to angle BCA by alternate interior angles. Then we know step 3, AD is congruent to BC by given. Am I going too fast? Okay, let me know. Step 4, AC is congruent to AC by reflexive. Five, triangle ADC, or DAC, we'll just say, is congruent to triangle BCA by side angle side. And then we've got to have our last step, right? Step 6, AB is congruent to CD. Why is that? Why is AB and CD congruent? What's the reason here? Say it louder. You can do it.
C, D, C, G, C.
Mm-hmm. Okay. This next one, why don't I mark it up and you guys try it? You ready? Okay. CD is perpendicular to AB, so we know that's going to make these right angles. D is the midpoint of AB, so these two are congruent. What else is congruent here? CD is congruent to CD by what again?
Reflexive.
Yeah. And then why are these triangles congruent? SAS. And then how would I know this last bit, that CA is congruent to CB?
C, D, C, G, C.
Okay, why don't you guys try writing it out? And I'll write it out and then we'll compare our answers. Remember the little upside down T is what again? Perpendicular. Okay, it took me 8 steps, guys. Okay, let's try it. I've got CD is perpendicular to AB, given. Angle ADC and BDC are right angles by definition of perpendicular. ADC is congruent to BDC by definition of right angles. D is the midpoint of AB, given. AD is congruent to BD, definition of midpoint. CD is congruent to CD by reflexive. ADC is congruent to BDC by side angle side. And CA is congruent to CB by CPCTC. Anybody confused about any part of that? You get something different? You don't understand why I put something extra in there that you didn't put? Anything? Okay, let's do one more where I mark up the picture and you guys do the proof, and then I'll let you do a whole thing on your own, okay? A couple on your own. Let's turn it over. Okay. Let's mark this up again and then we'll do it together, okay? Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. That's all my givens. What else is true about this picture? Good. That's reflexive. And then are these triangles congruent?
Yes.
By what?
Angle on both sides.
Good. Okay. So it wants M is the midpoint of JK. So we're going to have to say something about JM congruent to MK, or KM, excuse me, by CPCTC. And then we can talk about how they're a midpoint, okay? So I'm going to leave that up there. I am right now writing out my proof. You guys should too, and then we'll compare answers. I would put the givens on the same line just because they're really straightforward. Okay, it took me just 5 steps. We ready? Okay. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. We've got given. 2, OM is congruent to OM, reflexive. 3, triangle JMO is congruent to triangle KMO by angle side. So far so good? Step 4, JM is congruent to KM, CPCTC. Step 5, M is midpoint of JK, definition of a midpoint. How do we feel about that? Good? All right. Why don't we try 5 and 6 on our own, and then we'll compare answers. Go. Everybody do 5 and 6, both of them. Do you guys know what an isosceles triangle is? 2 sides are equal, so you're proving that 2 of the sides are equal. How you guys feeling? You ready? Or you need another minute? You had 2 proofs to do. Who needs another second? Anybody? We ready? Okay. Number 5, angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4 given. KM is congruent to KM reflexive. Triangle JMK is congruent to triangle LMK by angle side angle. JK is congruent to LK CPCTC. JKL is an isosceles triangle by definition of isosceles. If those two sides are congruent to each other on the outside, it has to be an isosceles triangle. Okay. Number 6. I put the givens on separate lines. You could have put them on the same. P is congruent to S, and O is the midpoint of PS. That's given. Let me make this look more like a P and less like a D. And then I have PO is congruent to SO by definition of a midpoint. Then POQ is congruent to SOR by vertical angles. And then POQ, triangle POQ is congruent to triangle SOR by angle side angle. And then RO is congruent to QO by CPCTC. And finally, O is the midpoint of QR by definition of a midpoint. That's a Q, by the way. How are you feeling? Good enough to try your homework? What?
O for number 3.
3 is PO is congruent to SO, yeah. Okay. Your homework is just a bunch more proofs to use for CPCTC. Okay? So you need to work on these. We will go over them before we take our quiz tomorrow. Okay? Your quiz is going to involve proofs with CPCTC and without. How do you know it doesn't include CPCTC? What would the proof say?
Like an angle.
Proof would just say a triangle is congruent to another triangle, right? And then you wouldn't use CPCTC. Okay? All right, I'm going to stop this recording. You can work on your homework.